Alright, so in this episode, we're going to be going over the second LeetCode problem, add two numbers. Alright, now let's take a look at what the problem states. You are given two non-empty linked lists representing two positive integers, positive being important, and the digits are stored in reverse order. That's also important. Each node contains a single digit. Again, the single digit is important. And of course, what we want is to add two numbers and return a linked list. So for the first example, what I want to do is just try to understand what a linked list in this problem is. So here we have a linked list. And the linked list starts with 7, goes to 4, and then the last node is 8, after of which is empty. So what does this linked list actually represent? Now this linked list represents 847, the number 847. So I think it's important to understand how a linked list is stored. We have single digits in each node. We know that the value is stored in reverse order. So even though the linked list starts at 7, goes to 4, and then 8, it actually represents 847, right? We have to reverse it to understand what the actual digit is. Cool. Let's take a look at another example. Cool. So now that we understand how a linked list is stored, we can understand the example that is given in LeetCode. So we're given two linked lists, right? Linked list 1 and linked list 2. Linked list 1 contains 2, 4, and 3. And that represents the number 342. And linked list 2 contains 5, single digit, 6, and 4, which represents 465. And what we want to do is add those two numbers, which is equal to 807. And of course, we don't want to return 807 or a linked list that says 807. We actually want to return a linked list that also contains single digits in the reverse order. So in this case, we want to return a linked list that says 708. Cool. Now we understand what the problem is asking for. Let's look at some solutions. Alright, now the first type of solution that we can have is a solution in which we stringify the number. What do I mean by this? Let's take a look. So what we can do, right, we can go through each node in the linked list getting the number. So here we would get 243, and we can just add that as a string, right? Cool. Then we can reverse the string, 342. And then we want to do the same with the second linked list, 5, 6, 4. So we get the string 5, 6, 4. We can reverse the string to 4, 6, 5. And then we can, of course, convert both of these strings into integers, 342 and 465. We can manually add the integers. This is pretty straightforward. And after we manually add these integers, we can convert this solution, 807, back into a string, 807. We can again reverse the string, 708. And then we can finally construct a linked list that represents this string, going character by character and adding the digits. So we would get 708. Cool. So that is one way to solve the problem, is to stringify these two linked lists. We want to stringify these two linked lists, and then we want to reverse these numbers, of course. We want to make them integers, add them manually. Now convert that integer into a string. Or I guess it doesn't really matter. In this case, we could just have it as integer. It doesn't matter. Reverse that string and insert the integer value of that string into the linked list. So that's a simple way to solve this problem. So let's try to understand the time complexity of this problem. The hardest parts of this problem, or solving this problem using the Stringify method where we stringify the entire linked list into a string, is actually going to be iterating through the linked list itself, right? So we want to iterate through the entire linked list. So again, we're going to be coming in at a big O of O of n, because regardless of, how fast our, reversal and additions are, we still have to traverse through two linked lists and, of course, add the third one. So all of these operations end up being O of n. And of course, we can look at each linked list as having O of n time. So it's going to say n plus n plus n equals 3n, which is equal to big O of n. And in terms of space complexity, again, we're going to have O of n because at the end of the day, we're going to need to make a list that contains all the digits in the final, or the summation, right? The summation is going to have at least as many as the first one and the second one. So it might have at least as many, and it might have maybe one more, so n plus 1 maybe. So that's still going to be big O of n. However, this problem is kind of like you're running away from linked lists. You're not really solving the problem at hand. So let's take a look at a solution that uses what linked lists are good for, because we're going to traverse through them anyway. We might as well do our additions as we traverse through them. So let's take a look at how we can construct an iterative solution that doesn't need to reverse the digits, convert them into string, add them, do all that extra jazz that the previous solution had. So let's look at this iterative solution, which I think is a little nicer, not necessarily cleaner or faster, but I just think it's, it allows us to have a deeper understanding of how linked lists work if we were to build out this solution, and that's always good because the whole point of practicing LeetCode problems is to get good at interviews, and we can't get good at interviews if we just continue to run away from, the hard problems, right? Or doing the problems the right way, I guess. And I think this is the right way to solve this problem. So what we want to do, right? We want to have a pointer 1 and a pointer 2. So once we add these pointer 1s and pointer 2s, we also want to initialize a carry that is equal to 0. And we want to go through this entire loop, right? We want to iterate through pointer 1's value, which is 2, pointer 2's value, which is 2, and the carry's value, which is 0. We want to add them, and after we add them, we get the summation, right? I'm just going to say that is equal to 7. And after we add them, we can just add a new node, 7. Cool. Now we want to iterate again, right? We want to add them. In this case, we're going to say 4 plus 6, right? 4 plus 6 plus 0 is equal to 10. Now remember, when we have a number that contains more than one digit, we want to make sure that we apply the carryover, because each node in our solution can only have one digit. So if it is the case that anytime we add up these three values, the linked list 1 value, we want to move the pointers, of course, the linked list 1 value, the linked list 2 value, and the carryover, and that is greater than 10, then we want to actually subtract 10 from that and say that the carry is equal to 1. Because we know when we're adding a number, if this becomes 10, then we want to carry over the number, right? We want to carry over the 1. So in this case, the value here is actually going to be 0, right? It's going to be 0, and the carry here, we're going to carry the 1. So again, we're going to move the pointer up, pointer 2 and pointer 1 at the same time, again. And this time, we're going to add these numbers, 3, 4, and 1, right? Again, thankfully this is not over 10, so we can simply iterate here. And of course, since this is a loop, we're going to actually have to go in one more time. And this time, we want to make sure that when we are creating our loop, we have our base cases check. So the first base case could be if the linked list 1 is empty, if the linked list 2 is empty, and if the carry is equal to 0. Right. So yeah, so that is the general approach to solving this problem. Cool. So now let's take a look at the big O of this problem. Again, we have to iterate through the linked list with our pointer 1 and our pointer 2. Cool. So that's going to be, of course, O of n, which is the length of the first list, and O of n for the length of the second one. And as we're doing this, we also have to maintain a carry variable. Again, maintaining this carry variable, not too complex. We're going to have to keep updating it n times possibly. Cool. So again, here we have the same solution, the same time complexity, which is O of n. And of course, in terms of the space complexity, we're going to be constructing a new list. As you guys remember from over here, the solution is going to be a brand new list. And as we are generating the nodes must at least be as big as the biggest linked list out of the first or second linked list. Because when you're adding two numbers, they have to be greater than than at least one of them, right? So in this case, again, we're left with O of n, space complexity. Cool. And of course, the easiest way to understand what's going on in the code is to use print statements. So let's take a look. Here, we're going over the first problem that is in the LeetCode example. So here, initially, I want to print out the first number, which is 342. Now the linked list that represents 342 is 2, 4, and 3. And the second linked list, 465, is represented by 5, 6, and 4. And now let's take a look at what's going on inside the function. So we come inside the function here, and we want to make some pointers for the first linked list and the second linked list. Now this is not exactly necessary, but I do it for clarity purposes. And we also want to have a carryover, because as you guys remember from the diagrams, if a number is going to be over or equal to 10, then we need to carry over the 1. And here it's the last setup that we're going to do. We're going to set a current variable equal to list node 0, and of course put our head of the linked list at that variable. You might be wondering why I did it this way. It's because it's the easiest to do. It's easiest to initialize a linked list before actually going through with the while loop, because otherwise it's going to have a nasty if-else statement inside the while loop, which is going to check if the linked list has been initialized or not. So it's easiest to just initialize a linked list like this, and at the end we want to return the next value. So just a quick small optimization. All right, so let's dive into this code. So we want to iterate over P1, P2, and current carry. So P1, which represents the first linked list, P2, the second linked list, and the current carry. If the current carry is equal to 1, we want to make sure that we do whatever is inside the loop. So here, as we can see, I print out the first linked list first value, the second linked list first value, and the current carry. So here we have 2, 5, and 0, because we know that we initialize current carry to 0. Now let's take a look at what is going on here, right? We set the current value equal to the current carry. That's obviously 0. Afterwards, we want to add the first value of the first linked list and the first value of the second linked list to the current value. If that value is over 10, we want to subtract by 10 and add the carry. Otherwise, we could just let the carry equal 0. In this case, right? In this case, 2 plus 5 is equal to 7. And 7 is not greater than or equal to 10. So the current value right here is 7, and the current carry is 0. So we add to the linked list that we have originally made, and we set that value to 7, which ends up coming out right over here. Okay, and then we iterate through. Here, what we're just making sure is if both P1 and P2 are none, then we can just break out of this iteration of the while loop and continue to the next one. Otherwise, we want to make sure that we traverse through the first and the second linked list individually, right? If one of them is none, we don't want to continue, because if we say P2 equals P2.next while P2 is non-existent, while it is none, that's going to cause an issue, which is why I have these few base checks. And of course, if they are both not none, then we want to iterate through both of the linked lists. So in this case, they are both not none, so we say, okay, we go to the next one. Cool. Again, now we're in the second iteration of the loop. I'm gonna go a little bit quickly here. So in the second iteration, we have 4 and 6, and that's what's displayed here. The current P1's value is 4, P2's value is 6, and the current carry is 0. Now, when we go through this section, we know that we have to add 6 plus 4 plus 0, which is 10. And because it's 10, we want to subtract the current value by 10. So we're going to get 0 for the current value, and the current carry is going to be 1. So that's what's displayed here. And that 0 is inserted into the linked list here, and that 1 is carried over to the next loop, right? So to the next loop, now we have 3 right here in the first linked list, 4 right here in the second linked list, and the current carry is going to be 1. So again, we're going to add all 3 of these values right over here. Cool, we add all 3 values, and that's going to be 8. That 8 is going to be set here, and again, we're going to enter this else statement. We know that the current carry is 0. So print that, and of course, P1 is none and P2 is none, so we break out of this section of the loop. And then we go here again, and we know that P1 is none, P2 is none, and current carry is equal to 0. So again, we can break out of this entire while loop, and we can exit the code, of course, and return head.next, which is going to be the value 708. Alright, I hope that cleared things up for you guys about adding two numbers which are stored in linked lists. Hope you guys enjoyed, and of course, if you made it all the way to the end of the video, I'd really appreciate if you can give me a like and a sub if you want to find out more. Alright, so that's going to be it for this week's video, adding two numbers that are in separate linked lists. If you guys enjoyed, please leave a like and subscribe if you want to find out more. Thanks for watching, and I'll see you guys next time.